Hey, Algebra 2 Honors students, this is just going to be a quick lesson for Unit 14, Day 4, a little bit more practice with sketching some trig functions, now including some more of the transformations that we've seen with changing the amplitude and the frequency. And then tonight, part of your homework will be a graphing calculator lab where you're going to explore some more transformations. There are certainly more things we can do other than dilating these functions, so we'll see that come up in tonight's graphing calculator activity. What we're going to do to get started is for y equals -2 sine x, we're going to graph it over two different intervals. We're going to graph it on one interval from 0 to 2 pi, and then see how the graph just looks different if we were to graph it from -pi to +pi. So let's go ahead and identify some of the key information about this sketch before we go ahead and set up some axes here. So we know that the amplitude of y equals -2 sine x is 2. With the negative out front, though, again, the negative doesn't get included with the amplitude, but what we know that represents is it's going to be a reflection over the x-axis. So what I'm used to seeing for sine x, it's going to get flipped over the x-axis. And then with the frequency of x only equaling 1, we know that that tells us that the period is 2 pi. That's how often it will take to complete one cycle of the graph, which is good information to know. So from 0 to 2 pi, since we're not going to the left of the x-axis like we are in this one at all, I'm going to put the y-axis pretty far on the left side of the page here. And let's see, let's draw my x-axis right there. To give myself some room, I'm going to label every two spaces as pi over 2. So if this is pi over 2, this would be pi, 3 pi over 2, and then this would be 2 pi. Given an amplitude of 2, I know that that has something to do with the maximum height that we reach. So I'm going to put every one space on the y-axis as another unit. So now that we have our axes set up the way that we have, I know that sine in general always starts at 0, 0. And then from there, usually the sine curve, by the time you get to pi over 2, would be up at the highest point at the max value of its range. But because it gets flipped over the x-axis, don't forget about that piece, it's going to go down to -2 first. And by the time you're back at pi, you're back at 0. 3 pi over 2, you're going to be up at 2. And then 2 pi, we're back down to 0. So an upside-down sine curve with an amplitude of 2 looks something like this over the interval from 0 to 2 pi. And we probably want to do too much to extend our thought process for what's happening from -pi to pi. In fact, we already know what half that graph looks like because we know what it looks like from 0 to pi. But just make sure that when you set up your axes over here for part B, that we think about probably putting the y-axis straight up and down the middle. This way, when we go to make our sketch, we have an equal amount of space to the left of 0 and to the right of 0, according to the interval that we're graphing over. So if I make the same scale, here's -pi over 2, so another 2 spaces would make that -pi out here. And then over here, we would get pi over 2 and pi there. Okay, so I want to sketch same exact function, but over a different interval. And it's going to look quite different. But we already know, like I said, what happens from 0 to pi. I can kind of steal that from over here. All right, so if I plot those 3 key points to connect them, here's the first part of the graph. And what we know about sine is that it is symmetric through the origin. So what's going to happen is when I go to -pi over 2, we're going to be up here at 2. And by the time we get to -pi, we're back at 0. So the part of the graph from -pi to pi actually looks like the good old sine curve that we know. Okay, that's what sine usually looks like. But because of the reflection that we're seeing here over this interval, here's what the sine curve looks like from -pi to +pi. So we'll try and get a little bit more practice with this. I know we're typically focused on, I would say, more often the positive side of the x-axis, but it's good to know, what's happening on the other side of the x-axis as well. Just to get a little bit more practice today, what we're going to change the directions to is we're only going to focus on sketching one cycle of each of the graphs. So when we have an increased frequency, maybe up until this point, we've sketched that frequency multiple times by the time I get to 2 pi. But what I want to focus on in, let's say, number 2 here is only sketching one cycle of the graph of 3 cosine of 4x. Okay. So in order to do that, let's identify the key information. So we have an amplitude of 3 here. We have a frequency of 4. And then we have a period of, well, if I do 2 pi divided by 4, that's going to reduce to pi over 2. Okay, 2 pi over the frequency would give you pi over 2 there. So I need to see one cycle of this graph, which is all I'm sketching, by the time I get to pi over 2. So if we create a set of axes here, we know that according to the amplitude, the max height that will reach is 3, 1, 2, 3. And the lowest point will be at -3. And I got to see cosine, which I know cosine looks like this in general, right? There's my cosine graph. I got to see that happen by the time I get to pi over 2, which is pretty quick. What that would tell me about the frequency is I would see 4 cos curves by the time I got to 2 pi if I was going all the way there. But I only want to sketch one cycle. So where I'm going to put pi over 2, I'm going to put pi over 2 right here, just so that I don't have it too crunched in together. If I put pi over 2 spaces away like I did up here, I have to do a really kind of thin cosine curve in between there. Just spacing it out a little bit gives me some space to work with here. But cosine starts at its max value of the amplitude. By the time you complete one cycle at pi over 2, it will also be at a max height of 3. In the middle of its cycle, it's down here at -3. And then between the start and the middle, and then the middle and the end, you're going to hit 0. So here's what one cycle of this graph would look like. Now, again, if I had extended this all the way to 2 pi, that would happen another 3 times to complete 4 cycles by the time you get to 2 pi. If I only am concerned about sketching one cycle, this is exactly what I would want to see. Okay. Let's try another one for practice. So if I have y equals -45 sine of 3x. Okay. So for this one, the amplitude is 45. And I certainly don't want you counting up 45 spaces, so we'll make a really nice scale, I promise, for that one. The frequency is 3, and therefore the period, if I do 2 pi divided by the frequency, that doesn't reduce any further, so I'll just write that as 2 pi over 3. All right, so let's set up some axes here to sketch one cycle of this graph. Okay. So as a quick off to the side sketch, upside down sine is what I need to look at here, right? So I know what normal sine looks like, but upside down sine looks like this. So in the end, I want to kind of see something that looks like this, but I want to make sure I label the axes appropriately. If the period is 2 pi over 3, that's how often it takes to complete one cycle of the graph, which is what I'm looking to do. So just to give myself some space again, I'm going to label this 4 spaces away as 2 pi over 3, which would make 2 spaces out pi over 3. Create an appropriate scale on the x-axis. And there's no right or wrong answer, by the way. Okay, if you chose a different scale, you'd be fine. All right, so for the y-axis, I'm going to make every 2 spaces. I'm going to be smart about this. Let's make it every 2 spaces 45. We can do whatever we want, can't we? But if I make every 2 spaces 45, I certainly don't want to, even if I chose 5s, that's going to take forever to count, 9 spaces up and down. So let's make it 45. So we're good to go. As long as you have it labeled correctly, you're good. All right, sine I know starts at 0, sine ends at 0, and in the middle of its cycle, it's at 0. Because of the reflection with that negative, in between the start and the middle, it's going to go down to -45 first, and then it will go up to 45 before it completes its first cycle. Okay, so that is just what one cycle of that graph looks like. Okay, let's just do one more. Let's do, for the last one, y equals -2 cos of x over 4. Okay, last one that we'll sketch. So for this example, amplitude frequency period, same thing we did before. Amplitude is 2. The frequency is 1/4. Okay. Careful with the period here. When you do 2 pi divided by 1/4, dividing by 1/4 is the same as multiplying by 4. So that's going to turn into 8 pi for the period. It takes a long time to complete one cycle. In fact, you should only see 1/4 of the cosine curve by the time you get to 2 pi, is the implication of that frequency. So if I set up some axes, okay. Let's see, I know I need a max height of 2 at some point, a lowest point at -2. This one, by the way, we're sketching upside down cosine. Here's what upside down cosine is going to look like in the ends, because here's right side up cosine. It's negative or it's upside down because of the reflection over the x-axis. Okay, we have to make a scale. We have to eventually finish this by the time we get to 8 pi. So you know what? I'm going to make every space another pi. So here's 1 pi. This would be 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. We have to finish that cycle by 8 pi right there. Okay. Well, what does upside down cosine do? It starts at the lowest point in the range. It also ends at the lowest point in the range. In the middle at 4 pi, it's at the highest point of the range. And in between the start and the middle and the end, you go through 0. So you're going to get a graph that looks something like this. Kind of messed it up a little bit at the end, but you guys got it. All right, that is what -2 cos of x/4 would look like over just sketching one cycle of the graph over this domain from 0 to 8 pi. Okay, so that's pretty much it for today. There are going to be some more transformations we learn about, like I said, in the graphing calculator activity that you got coming up. If you have any questions about these examples, let me know next time we're in class. Have a good day.